Hey guys, today we're going to go over some basic trig identity properties. First is the reciprocal properties. Sine and cosecant are reciprocals of each other. So sine is 1 over cosecant. So sine x equals 1 over cosecant x. And cosecant x is 1 over sine x. Cosine and secant are reciprocals of each other. So cosine x is 1 over secant x. And secant x is 1 over cosine x. And tangent and cotangent are reciprocals of each other. So tangent x is 1 over cotangent x. And cotangent is 1 over tangent x. The quotient properties. Tangent, which we've learned in chapter 6 in our last unit, is y over x, which means tangent x is sine x over cosine x. And cotangent is cosine x over sine x, the reciprocal of tangent. Sine squared x plus cosine squared x equals, and we're going to have to do some work to figure out what that equals. So here's how we're going to start. So there's a right triangle, and I'm going to put theta right here. So here's my opposite, my adjacent, and my hypotenuse. And I'm going to use the Pythagorean Theorem to figure out what should go here. So according to the Pythagorean Theorem, the two legs squared, that's opposite squared, plus adjacent squared, equals the hypotenuse squared. If I divide both sides by hypotenuse squared, I can say that this left side equals 1. The left side I'm going to split up into two fractions. Opposite squared over hypotenuse squared plus adjacent squared over hypotenuse squared. So I just took this fraction where they're both over hypotenuse squared and split them up so opposite and adjacent squared are separate, both over hypotenuse squared. Opposite over hypotenuse is sine, so opposite squared over hypotenuse squared is sine squared. So sine x squared plus adjacent over hypotenuse is cosine squared cosine x squared. Sine x squared, well, sine x in parentheses squared is the same as sine squared x. In parentheses, cosine x squared is cosine squared x. So sine squared x plus cosine squared x equals 1. So the first Pythagorean property is sine squared x plus cosine squared x equals 1. Okay, next is tan squared x plus 1 equals. We're going to start with what we already know. Sine squared x plus cosine squared x equals 1. Now we've already got a 1 here, so I need to turn this spot right here into a 1. And I'm going to do that by dividing everything by cosine squared x. Okay, I'm going to split this into two fractions here, sine squared x over cosine squared x, plus cosine squared x over cosine squared x, that's 1, equals 1 over cosine squared x. Sine squared x over cosine squared x. We look up here, sine x over cosine x is tangent x. So sine squared x over cosine squared x is tangent squared x. Plus 1 equals 1 over cosine x is secant x. So 1 over cosine squared x is secant squared x. So tan squared x plus 1 equals secant squared x. The last one, 1 plus cotangent squared x. We're going to start again with sine squared x plus cosine squared x equals 1. So we're starting with this again. And I'd like you to pause this and try to simplify this left side down to 1 plus cotangent squared x and see what the right side equals. After you've tried it, then click play again and see if we match. So if we want this to be a 1, we're going to have to divide both sides by sine squared x. Sine squared x over sine squared x is 1, plus cosine squared x over sine squared x equals 1 over sine squared x. So we've divided everything by sine squared x to get that 1 here. Cosine squared x plus sine squared x. Cosine over sine is cotangent. So cosine squared over sine squared is cotangent squared. 1 plus cotangent squared x, which matches what's up here. And 1 over sine squared x. Cosecant is 1 over sine x. So 1 over sine squared x is cosecant squared x. So 1 plus cotangent squared x equals cosecant squared x. So those are the 3 Pythagorean properties. So we need to simplify each expression. So example 1, cosecant x over cotangent x. We want to simplify that as much as possible. Here's your strategy. Put everything in terms of sine and cosine. So cosecant, we want to change that to sine or cosine. Cosecant is 1 over sine. So I'm going to change the numerator to 1 over sine x. Cotangent is 1 over tangent, but that doesn't put it in terms of sine and cosine. So I'm going to use the quotient property. Cotangent is cosine over sine, and that's the terms I want, sine and cosine. So cotangent I'm going to replace with cosine x over sine x. So it's 1 over sine x divided by cosine x over sine x. Now if I multiply this outer loop, I get a numerator. So that's sine x. And the inner loop will give me the denominator. That's sine x times cosine x. Sine x over sine x cancels. So I get 1 over cosine x. And I've got one more move that can simplify that for me. 1 over cosine is secant. So that 1 over cosine x, I'm going to simplify to secant x. And that is the simplest form that I'm going to be able to get. Okay, now simplify cosine theta times tan squared theta plus cosine theta. The first thing I notice is I've got two terms, and both of them have cosine theta. So I'm going to factor that cosine theta out. So I'm going to have cosine theta times, when I divide this first term by cosine theta, I get tan squared theta. And when I divide the second term by cosine theta, I get 1. So if I was to distribute that, I would get cosine theta times tan squared theta plus cosine squared theta. So essentially what I just did was undistribute a cosine theta. All right, so tan squared theta, that sounds kind of familiar. So I'm going to go back to page 1. Tan squared theta makes me think of a Pythagorean property. Tan squared theta times tan squared theta x plus 1 equals secant squared theta. So what I've got here is tan squared theta plus 1, and according to the Pythagorean property, that is equal to secant squared theta. So cosine theta times secant squared theta. So I use the Pythagorean property to replace this with secant squared theta. Okay, now back to those properties. I want to put secant in terms of sine or cosine. This one's already cosine, so I'm good there, but I need to turn this into terms of sine or cosine. So secant is 1 over cosine. So secant squared is 1 over cosine squared. So cosine theta times 1 over cosine squared theta. Now if I multiply these, I'm going to get cosine theta over cosine squared theta. So basically this is over 1. So I'm multiplying the numerators and the denominators. Now I've got cosine over cosine squared. So I can cancel out a cosine from the numerator and the denominator. When I cancel a cosine out of the numerator, I get 1. When I cancel a cosine out of the denominator, it's cosine squared, so I get cosine theta. And I'm going to go back to the front one more time to see what I can do with that cosine theta. I've got 1 over cosine theta, and that equals secant. So that 1 over cosine theta, I'm going to replace with secant theta. And that is the simplest form I can put that in.